This is AP Calculus, section 5.1 through 5.4 test review. Problem number 1 is a multiple choice question. It says estimate the area under the graph of f of x equals 16 minus x squared from x equals 0 to x equals 4 using 4 rectangles and right endpoints. Okay, so this is critical information to making sure that we do this problem correctly. We don't need to sketch a whole graph of our function, but we do need to be thinking about if we're looking at the x-axis from x equals 0 to x equals 4, so 1, 2, 3, 4, and we're building rectangles here. You know, who knows what our function looks like? It doesn't matter. But what matters is that if we're choosing to do rectangles with right endpoints, then the locations where we're going to be calculating the heights are going to be at x equals 1, x equals 2, x equals 3, and x equals 4 for our right endpoints. And since we're doing 4 rectangles, we know that our delta x is going to be equal to b minus a, so 4 minus 0 divided by n, which is 4. So that tells us that our delta x is 1. And our area then is going to be equal to our delta x times the heights of our rectangles. So f of 1 plus f of 2 plus f of 3 plus f of 4. So then when I go ahead and I plug my values in here, my delta x is 1. F of 1 is the value of the function when x is 1. Well, when I plug 1 in, 1 squared is 1, and 16 minus 1 is 15. F of 2 would be 16 minus 4, which would be 12. F of 3 would be 16 minus 9, which is 7. And f of 4 would be 16 minus 16, which is 0. Right? So then I get my area to be 34. So that tells me that letter H is the correct choice for problem number 1. In problem number 2, let f of x be x on the interval from 0 to 1. Let the interval be divided into 2 equal subintervals. Find the value of the Riemann sum if each x value is the midpoint of its subinterval. So again, just kind of sketching a little picture here. Here's my x-axis, and I'm only going from x equals 0 to x equals 1, but I'm dividing this into 2 equal subintervals, so I know that this would have to be x equals 0.5, and wherever my heights are, if I'm doing midpoints, then they would have to be wherever the value of the function is here and here, which would be at x equals 0.25 and at x equals 0.75. So this time, my delta x is going to be equal to my b minus a, so 1 minus 0, divided by the number of intervals, which is 2. So my delta x is 1/2, and I know my area is going to be approximately equal to my delta x times, and then the 2 heights for my 2 rectangles for my midpoints are going to be at f of 0.25 and at f of 0.75. So then when I go ahead and I plug in my numbers, my delta x here is 1/2. F of 0.25 is just 0.25 because my function is just x. And f of 0.75 is 0.75. 0.25 plus 0.75 is 1, and half of 1 is 0.5. So looking for an answer equivalent to 0.5, which would be letter D, which is 1/2. Problem number 3 says if the integral from 0 to 3 of f of x dx is 4, the integral from 3 to 6 of f of x dx is 4, and the integral from 2 to 6 of f of dx is 5, find the value of the integral from 0 to 2 of f of x dx. Okay, well, basically I'm trying to use the given information to figure out the integral from 0 to 2. So if I know the integral from 0 to 3, so the integral from 0 to 3 of f of x dx, if I were to add to that the integral from 3 to 6 of f of x dx, then that would give me the total area from 0 to 6. Now, if I know that the area from just 2 to 6 is 5, and I were to subtract that off, then that should give me the integral from 0 to 2 of f of x dx. So plugging my values in here, 4 plus 4 minus 5 is going to give me 8 minus 5, which is going to equal 3. So the correct answer here is going to be letter B, which is 3. Multiple choice problem number 4 says find the integral, or the value of the integral from 0 to 1 of x plus 1 squared dx. Okay, so there's more than one way to do this. Okay, the first way that we can do this is by actually doing the calculus, right? Integrating my function and then evaluating it over the integral from 0 to 1 using the fundamental theorem of calculus. And although it looks like, we might have to do a u substitution, it's okay because the derivative of x plus 1, because again, we have to think about the chain rule here because we do have a composition of functions, x plus 1, that function is being squared. However, luckily, the derivative of x plus 1 is just 1, so we do not really have to worry about the chain rule in this case. We can easily integrate this. So the first way that I would do this is I would say, well, this is the integral from 0 to 1 of x plus 1 quantity squared dx, which is going to be equal to x plus 1 to the third power, but then I have to go ahead and divide by 3 or multiply by the reciprocal of the exponent in front, so 1/3 times x plus 1 cubed, and that's going to be evaluated over the interval from 0 to 1. So when I plug this in, I get 1/3 times 1 plus 1 quantity cubed minus 1/3 times 0 plus 1 quantity cubed, which is going to give me 1 plus 1 is 2 and 2 cubed is 8. So my first term here becomes 8/3. 0 plus 1 is 1. 1 cubed is 1. 1 times negative 1/3 is just negative 1/3. So I end up with a value of 7/3, or as a decimal, this would be 2.3 repeating. Okay, now the other way that we could do this problem is something that we have not really talked about yet, and this is using the FNINT key on your calculator, which stands for finite integral. So right now, I am going to show you how to do this for the first time ever. Okay, and again, this is use the FNINT on your calculator. Okay, so we're going to be, again, looking at the integral from 0 to 1 of x plus 1 squared dx. So you're going to bring up your graphing calculators. Sorry, this is going to take me a moment to open. Just adjusting my window here a little bit. Oops. Okay. And if you go under second level calculate, oh, hang on. I lied. You go under math. There we go. You go under math, and it is number 9, which is the FNINT, and you hit enter. Okay. Oops. Okay, you need to be in your home screen here, kind of where you do math problems. So if you're not there, you're just going to go to second level quit, which is above your mode key. That should take you back to your home screen. Okay, so you need to be in the home screen to do this. Sorry, that was my trouble a second ago. So then you're going to go to math, and under math, you want number 9. Okay, so when you click that, see how this looks just like an integral, right? So first we're going to type in our limits of integration, which are going to be from 0. I'm going to arrow up here to 1. Okay, now we type in our function, and our function is x plus 1 quantity squared. So we're going to need another parenthesis, and then it's x plus 1 parenthesis, and then that is squared, and then dx, because that's our variable. Okay, so the calculator is actually going to tell us the exact value of this integral when we hit enter. There it is. You can see 2.3 repeating. So that's the same answer that we got when we did our calculation. Now, I want to caution you, this is the first time that I've shown you this for a reason, because you need to be able to calculate the value of integrals without the use of your calculator for the AP test. However, if you are doing a portion of the test where graphing calculators are allowed, then certainly you can use that key on your calculator to do the work for you. And on a quiz or a test for me, where I'm requiring you to show the work, you can still do the work, but then you can use that key to check your work and make sure that you got the right answer. Okay, so we will discuss this in class as well. But just a new little trick to help you figure out the exact value of an integral.